Dear friends, good evening. Maths Aspirants is a collective of mathematics students, research scholars, postdoc fellows, and faculty members across India, initiated by myself in 2017. And we used to organize several online programs to help the students who are preparing for competitive examinations in the field of higher mathematics. So as a part of the online problem solving session series, today we blessed to have Mr. 𝕸𝕚𝕚𝕟𝕤. He is currently pursuing PhD at IIT Madras with us to handle a session on problems from abstract algebra. As all of you know, the CSIR net examination is very near. It's going to happen on the next week. So I'm sure that today's session will be really helpful to all those who are seriously preparing for CSIR net and other competitive examinations. Today, Debajyoti will discuss some concepts and some problems from the area of abstract algebra. Mr. 𝕸𝕚𝕚𝕟𝕤 is from West Bengal, and he qualified IIT JAM, CSIR NET, GATE examination, extra. And currently, I told you that pursuing PhD at IIT Madras. Now, I think in the third year now. So I welcome everyone to this program, and I would like to express my sincere thanks and gratitude to Mr. 𝕸𝕚𝕚𝕟𝕤 for being with Math Aspirants, and also for handling today's session. For PhD is actually a very very difficult to find out time for other things. There will be a lot of things to do as a part of the PhD itself. So still, he's very eager to handle such a session in our platform. So I am very thankful to him. So I welcome everyone to this program again, and welcome 𝕸𝕚𝕚𝕟𝕤.
Yeah, thank you for the kind introduction. Yeah. Good evening, everyone. So I'm Debajyoti. I'm currently a PhD student at IIT Madras. I am working in mainly algebraic number theory, elliptic curves, 𝔸𝕚𝕚𝕚𝕟𝕒. Maybe you have heard algebraic number theory. If you have heard number theory, maybe there are lots of number theory branches like algebraic, analytic, transcendental. So means in algebraic number theory, we mainly do number theory problem using the tools from algebra. Okay. So, okay, maybe we can start sharing the screen. Let me share the screen. Okay, so I'm planning to discuss at first group theory. I'll discuss some concept, and I'll surely do some MCQ problems surely. And after that, last 45 or 50 minutes, I will cover ring theory and little bit field theory. It's difficult to cover a whole group ring field in one session, but I will try as my best. Then I will use some standard results, theorems, or some facts from some standard algebra book. If you are interested in the proof, then you will read any standard book, you will find the proof. No problem. Okay. Okay. Even if you have any doubts, please ask me. Please interrupt me, and feel free to ask me anything during the discussion. Okay. So, okay, since I'm interested in number theory, that's why I said this problem very fast. Means for this, you do not need to know too much theory. And this was asked in December 2023. Yeah, 2023. So we'll solve this problem. Means so you have Z mod 89Z. You have to find the value of this, like 1 power 37 plus 2 power 37 up to 88 power 37. How will you solve this? You have this expression, and you need to solve means modulo 89. Even for this, you do not need to learn anything, means any number theory or any group theory. You do not need to learn all those things. If you have knowledge modular arithmetic relation, then you can do this problem. Yeah, how will you solve this problem? Yeah, this is interactive session, so please try to interact with me. Okay. Yeah, you can turn on your mic and let's say.
Sir,
Yeah, sure.
so will we substitute 88 with -1?
Yeah. So good. So at first calculate this thing. 1 power 37 plus 88 power 37. We know 88 congruent to -1 modulo 89. So you can substitute this as in modulo 18. -1 power 37, 1 power 37 is 1 and this is -1. So this is 0. Similarly, next term is 2 to the power 37 and that will be 87 power 37. This is also congruent to 0 mod 89. In this similar fashion, you can prove like next term will be 3 power 37 plus 86 power 37, that is congruent to 0 modulo 89. In similar way, what will be the last term in this direction? 43. So total here 88, right? What will be the last term then? Hello. Yeah, please try to interact. This interactive session.
So last would be 43 and 40 would be 40, 45.
43 and
No, 43 and 45.
no, but no, because see 2 plus
What about
8 is
44
89.
and 44?
44 and 44 is not possible. 44, 45 possible, right? See the term 1 and 88, sum of these two is 89, 2 and 87, 89, 3 and 86, 89. So 44 and 45, 89. So this quantity is 0, right? Is it clear? Or you have
Yes,
any doubt?
sir.
Yeah. So now can we generalize this? This is one particular problem up to 88. How will you generalize this problem? Any guess or any comment? How to generalize this problem? Yeah.
Here the power is given to is 37. If it
Yes.
was any odd power, it will work.
Okay. So one way to generalize this, if you have 1 power some 2n plus 1 up to 88 power 2n plus 1 mod 89, this is 0. So this is the one way. Any other way? Yeah, that's fine. Any other way to generalize this problem? Like if in the exam they ask for this, n is any unnatural number, so that will be 0. Any other way to generalize this problem?
Instead of
Can we
89, if we have any integer,
Sorry, can you repeat once again?
instead of 89, if we have any integer young, then
Okay.
1 to m minus 1, where the summation is from 1 to m minus 1, again it will be considered.
Good. Yeah, means if you have 1 power some 2k plus 1 up to right? This is 0, right?
Yes.
Yeah. Even like similar kind of problem in recent time, they asked so many number theory type, this type of questions in CSIR net. Like from group theory, they will ask 1 or 2 questions, but rest 2-3 questions will be from number theory. like in 2009, 20 or so, not 20, after COVID, like first exam 22. That year they asked 3 or 4 questions from number theory. So these are one questions I have discussed. Yeah, you can generalize this way and you can generalize this way. Okay, fine. So any doubt? If you have any doubts, feel free to ask me. Is it okay, right?
Yes, sir.
Okay. Okay. So let's recall some group homomorphism things. Then we'll move to again MCQ. So what is group? Group is some algebraic structure with some extra properties like associativity, inverse, identity. You all know, you all are familiar with what is group. Suppose you have two groups, G with respect to star and G prime. And phi is a map from G to G prime. If phi satisfies this property, then we will say that phi is a group homomorphism. And if this homomorphism is injective and surjective both, then in that case, we will say that phi is an isomorphism. Group homomorphism plus bijective. Then we will say that phi is an isomorphism. And kernel phi is those element which goes to identity element of G prime. And this is a subgroup of G, and image of phi, this is subgroup of G prime. Even you can prove also kernel of phi is a normal subgroup of G. And this first isomorphism theorem you all are familiar, like car phi is a normal subgroup of G, and this quotient group is isomorphic to phi. And if phi is onto, in that case, this quotient group is isomorphic to actually G prime. Okay, you all know these things. Good. Okay, so there was another question. Okay, yeah, this question. This was asking June 2024. How you have to find, this is cyclic group of order 150 and this is cyclic group of order 90. You have to count how many group homomorphisms are there from Z mod 150Z to Z mod 90Z. How will you count?
Different images of the generator.
Sorry, can you repeat once again?
Right. Instead 150, 1 is 1 plus 150 instead is generator. So
okay, yeah, 1 is the generator. Yeah,
we are saying different images.
okay, okay. So anyone else wants to give any input? Yeah, feel free to tell anything.
DCD of 150, 90.
Yeah, that's just formula. Yeah, that's fine. But how will you count? Yeah, like
Sir,
if you have, yes, continue.
we know that identity must go to identity. So 1 will go to 1.
No,
But
here identity element is 0. In Z mod 150Z, identity element is 0.
sorry, yes, 0 to
Yes. Yeah, 0 goes to 0. Yes, f of 0 is 0.
sorry, I was using ring idea.
Yeah. That thing I will go later. Yeah, ring
Oh.
So yeah, number of group homomorphism, we all know this GCD of m comma n. So in this case, m is 150 and n is 90. So you have, I think, 30. But do you know why means this formula came? Just briefly, if you can say. Yeah, for competitive exam purpose, if you know the formula, that's okay. But if you see after NET, you have to give some PhD interviews and all those things. So that if you say that the number of group homomorphism is GCD MN, they will surely ask you give the proof. Like suppose they will ask you find group homomorphism from Z mod 4Z to Z mod 10Z. Explicit group homomorphism. How will you find explicit group homomorphism? So according to this formula, you have GCD of 4, 10. That means you have 2, right? So give me one is trivial. All f of x is 0 for all fx belongs to Z mod 4Z. What is the another one? How will you find? Is the question clear? Means I am asking you how will you find the explicit homomorphism? Means what is the process? Do you know? Yes, sure.
We can look at the elements of domain, and their order should be same in the as the image. So
Why
if
order
we
will be
take
same? Why order will be same? If you are talking about only group homomorphism, for group homomorphism, why order will be same? Yeah, for isomorphism, I agree with you, but not for any general group homomorphism. Order will be same. Yeah. Anyone?
So let us take any homomorphism f from
Yeah.
z over 4 z2 z2 over 10 z.
Yeah.
That's defined as f of z is equal to z over 10 z.
Yes.
Then f of x is equals to, I mean f of x is equals to, here if I assign some y means we need x is of the form
Mhm.
z plus 4z. I mean a plus 4z.
Okay. Okay.
Y
Yes.
y
Question. Okay, but okay, let me tell you. So you have this group Z mod 4Z, and here also that group Z mod 150Z or Z mod MZ, all are cyclic groups. That means you are asked to find a group homomorphism from cyclic group to any group. Let's take any group. So how will you determine this type of group homomorphism? So for cyclic group, you know the generator, right? What is the
yeah.
generator? Suppose let's take this G, and this G is generated by A. So if you are asked to determine group homomorphism from cyclic group to any group, then if you know the image of the generator, then that is enough for you. You can fully determine the full group homomorphism. Means for cyclic group, if you know the image of generator, then you can determine full group homomorphism. So here also, what is the generator in Z mod 4Z? What is the generator?
1 and 3 are the generated.
Let's so just fix f of 1 is x, and x is an element from Z mod 10Z. If you know what is f of 1, then you can easily find values of f of 2, f of 3, all those things. Even for a group homomorphism, you know order of f of a divides order of a. This thing you can use. Right? So here order of f means order of x. That is divides order of a means 1. So that means order of x divides, what is the order of 1 here? 4. This is one relation. Again, x is an element of Z mod 10Z. So that means order of x divides 10. So order of x is a divisor, common divisor of 4 and 10. What are the possibilities of order of x then? 1, 2. Now find how many elements are there of order 1 and 2. That will give you the homomorphism. And the homomorphism will be defined by f of x is ax. Not ax. F of a will be ax because I have fixed f of 1 is x. So f of 2 will be, how will you find f of, see, f of 1 is x. So f of 2 will be f of 1 plus 1. That means f of x plus f of x. Sorry. F of 1 plus f of 1. So that will give you 2x. Similarly, f of for any f of k, that is kx. That's why GCD is coming in the picture from this thing and this thing. You can easily see. That's why GCD means in the formula GCD is coming. Is it clear? Means you have to fill those gaps, like you have to do by your own. Is it clear? Means whatever I have said.
Sir, but in the formula, codomain should be a cyclic group, right?
Not necessarily. Here, not necessarily. Here it should be any group. Yeah, but for this means for GCD, obviously you need here cyclic. Means here GCD, I'm saying for this case, left side case, but right side case, it's true for any setup. Here, any cyclic group. Here, you can think any group. Okay.
Okay, sir.
Yeah, but yeah, for left side, you need both sides together. Is it clear to
Sir,
everyone? Yeah.
Because
Sure.
the codomain is a cyclic group, we have for every order there is only one such element.
Yeah.
So so that we have for one we have one which is 0, and for order equal to 2 we have one element here. But if it was any group, then we have to specifically count how many.
Yes. Like yeah, I will go
many.
to that. Yes. Yes. Like for this, I will go to next. Okay. Yeah. Surely. Is it clear? Yes.
f of 1 is equal to 0 if we take
F of 1 is
0.
if f of 1 is 0, then your homomorphism is just trivial homomorphism, right? All element will go to 0, right?
There must be 3, right? 3 homomorphisms.
No, not 3. Like order of x is 1, that means that x is 0, right? And from because GCD is 2, right? Only 2 homomorphism is there.
When f of 1 is equal to 1, one case, f of 1 is equal to 2, other case, f of 1 is equal
F
to
of 1
0.
is equal to 1. But your that has to be satisfied now. Order of x is 1 or 2. For if the order of x is 1, then x is 0 element. Now find the elements here which have order 2. Is it clear?
So it will be x equal to 0 and x equal to 5.
Yes, 0 and 5. So the homomorphism will be trivial homomorphism, and second one is fx equal to 5x. That's all. Clear?
Yes, sir.
Yeah. Good. Okay. Now suppose you have Z and you have here any group G. G is any group. Z is infinite cyclic group. Right? And G is your any group. Here also, since the group is cyclic group, that means if you know and Z is generated by +1 or -1. So if you know the image of the generator, that's enough. So let's fix f of 1 to be x. And G, that group, take G with respect to plus, okay? Means I am taking additive group. Then how will you define f of k? F of k will be k times x. This is the homomorphism. So that means we have one theorem. Let G be a group and x not equal to E be an element of G. Then there exists unique homomorphism f from Z to G such that f of 1 is x. Because if you fix the value of f of 1, then you have only one homomorphism. Is it clear? If G is multiplicative group, if you take with respect to multiplication, then your f of k will be x power k. And if the group is addition with respect to addition, then that will be kx. So there exists an unique homomorphism such that f of 1 equal to x. Now suppose this is fine, right?
Excuse me, sir.
Yes, sure.
Sir, please, I cannot understand the theorem actually what are saying. Yeah, if G is any group and if
Yes.
we take any non-identity element from G,
Yeah.
then there is then always there exists f of G to
Unique
G such that f of 1 is equal to x.
Yes.
Here existence is the important. Okay.
Yes, because Z is cyclic. From cyclic group you have existence.
Okay.
From cyclic group you have existence, and for uniqueness, suppose you have another such Z. Okay. For uniqueness, you can prove easily also uniqueness also. Like you have another G such that G from Z to G such that G of 1 is also X. Then similarly, G of K will be G of 1 plus 1 up to 1. That means G of 1 up to G of 1. Its value is X, so there is Kx. And this is same as f of K. So unique homomorphism from Z to G. Yeah, the condition is you need to fix the image of the generator. That's the crucial thing here. Is it clear?
Okay. Yes, clear.
Yeah, is it clear to everyone? Or you have any doubts? Yeah, if you have any doubts, feel free to ask me. Good. Now,
I have a doubt.
yeah, sure.
Here, f of 1 equals to x. Okay.
Yes.
This one you are considering the generator of Z, right?
Yes, generator of this group. Yes.
Instead of this 1, can I replace -1?
Yes, you can. Like for negative values, like from f of 1, you get f of k. So from this, you have f of k is kx. So if you have f of -1 is x, then you will get f of -2. How do you get? F of -1
Plus f of -1.
So that is 2x. So for negative values, you have here positive. So what will be the value of f of 2 then? Right? So if you fix f of 1 to be x, then negative value will be minus of that. But if you fix f of -1 to be x, then f of positive value will give you minus of that, right?
Right, sir.
Yeah. Good. So if you
So-
are comfortable with this,
sorry.
now we can, yeah, sure. Yes, sure. Yeah.
We generalize to a group with multiple generators. A cyclic group of multiple generators. So then any
Yes.
homomorphism can be uniquely identified by its action.
Yes, surely. Yeah, if your group G, that cyclic group has multiple generators, you can define, means you are free to choose any generator and you can define homomorphism. Yes, surely. Yeah, that's the beauty with Z. That's why Z as a group, even as a ring, similar kind of setup also holds for a ring. That's why Z as a group is so special, because you have take G, that G to be anything, no abelian, non-abelian, cyclic, non-cyclic, whatever you want. You have this theorem. Even means I'm not giving you, from this theorem, you can find order of any element, means you can define order of element in terms of kernel of this map. That's I'm not going today, but you can define. Means you have seen order of an element. Order of an element you can define from the kernel of this F. This F is so special. That's why. Because using this theorem, you can define order of an element. And similarly in ring, if you replace G by any arbitrary ring, from that ring homomorphism, you can define characteristic of a ring that from of that arbitrary ring. I'm not going today. Maybe if I take any other session, then I will surely do this thing. So my aim is to, we will use this theorem to count multiple group homomorphism. Like suppose in exam, you are asked to find how many group homomorphism are there from Z mod to this is. So you are giving exam on 2025, so they will ask this question. So how will you calculate this? Do not need to memorize all those formula that if Z mod MZ to Z mod MZ GCT of MN, this thing, those things. Just use whatever I have discussed. You do not need to memorize all those things. So how will you count this homomorphism? Just learn the technique. Means instead of looking some notes, means there is some list of that if the group is this and the another group is this, then there will be 5 homomorphism or 10 homomorphism. Do not look those things. Yeah, for competitive exam purpose, that is little bit beneficial, but not for long run. Means if you are going to give interview or if is any situation like suppose in exam you have forgotten the formula, so what will you do? So just use this thing. What this theorem tells us, if you fix the value of 1, then you have unique homomorphism. That means how many x are there, depending on that you have cardinality of x, right? That means here you have f of 1 is x, then that is unique. So how many choices of x are possible?
2025.
25. So number of group homomorphism is 2025. Now the question means if you want to generalize this, you have Z to Z, then number of group homomorphism is
Order of G.
right. Good. So you do not need to remember anything like any formula or anything. Like
But suppose G is infinite group means.
so there is infinite number of homomorphism. Like for example, you have G is Z. How many group homomorphism there? Yeah, there are infinitely many group homomorphism. Okay, let's assume here G is finite. Infinitely many group homomorphism. Okay.
Okay.
Yeah. So just if you are asked to Z to Q also, just pick f of 1 is x. So x you can take any rational number. So for any x you will have one unique homomorphism. So you have infinitely many homomorphism, right? Clear? Is it clear?
Yes, sir.
Yeah. So like whatever I discussed, you can make it to several number of MCQs. Like in exam, they can ask you that if from Z to Sn, the number of group homomorphism is n factorial, Z to An. So you can construct lots of MCQ, MSQ, whatever you want. Okay. Now reverse it. Suppose you are asked to find group homomorphism from G to Z. G is any group. What will you do? How will you approach? G is any group. Is the question clear? Yeah.
If we assign the image of identity element, then we can.
See, for identity element, we will go to identity element. That will give you trivial homomorphism always, right? That will not give you non-trivial thing.
So we can go with the x goes to order of x.
X goes to order of x. This homomorphism You are talking about?
Oh,
Yes,
homomorphism.
sir.
Will it be homomorphism? First of all,
No, sir.
like
Multiple elements will have the same order.
same order. Even not only that, that will not be.
As
Like
CZ has two
if you have
characters.
if you have G to be Z in particular, then we have seen that this has infinitely many homomorphisms, right? So okay, let's break down this problem. Case 1, G is finite group. Okay. Now, can you use first isomorphism theorem? Can you argue whether any group homomorphism is possible or not? Just use first isomorphism theorem. Can you say anything? G is finite group. Yeah, just turn on your mic and
So we know G by kernel of F should be isomorphic to image, which is in this case Z.
not Z, because if it is not onto, then it will not give you Z.
Oh.
So to be Z, you
Image of F.
yes, image of F. Yeah, sure.
That is a subgroup of Z.
Yes,
So
good.
should it?
So suppose you have G to Z, then you have by first isomorphism theorem isomorphic to F of G, that is a subgroup of Z. So that means F of G that will of the form NZ, right? Because all the subgroups of Z are of the form NZ. And now observe that your G is finite group. So cardinality of G is finite. That will imply cardinality of F is finite. So that will give you this is finite, right? But here you can observe that this is infinite group. So finite group, how can it be isomorphic to an infinite group? So this case only trivial homomorphism. Is it clear?
Yes, sir.
Good. But for infinite case means if your G is infinite, what will you do? Suppose the group is infinite. How will you prove? Any input from your side? Like, see, here you can see that
G
if,
is cyclic.
if G is Z, then you have infinitely many homomorphisms, right? Yeah,
If
so
G is a cyclic group, then
then
again we have infinite number of homomorphisms.
only you need cyclic. Suppose I am giving you G is Z mod 5Z. So this is cyclic group. So you should suppose take G to be Z mod 5Z. Then so G is infinite cyclic. In that case, you have infinitely many group homomorphisms, right?
Yes, sir.
Yeah. Like for example, if you consider this Q to Z, is there any group homomorphism from Q to Z?
Zero group homomorphism.
Why there is no such means non-trivial homomorphism is not there? Why? Can you prove? Zero is always there. Between any two groups, zero homomorphism is there. So I am asking you, is there any non-trivial group homomorphism from Q to Z? Anyone else? Like you should interact, no? Otherwise,
I think there is no group homomorphism between themselves.
why? Yeah, why?
Because Q is not generated by anyone. No?
So
So if Q is generated by some element A,
so you are saying if you have G to G prime, if this is not cyclic, then there will be no homomorphism. That's the claim.
in this case only I'm telling.
Okay, but okay. So G is okay. So Q is not generated by any element. Then
If it were generated by any element,
yeah,
then we can assign f of that generator is equal to some x.
but it is not generated, na. So what will you do? Suppose that group is not generated by something. So then what will you? What will be your approach? Okay, let's do it. Yeah, Drew. Yeah, you can.
So by the first isomorphism theorem,
Okay.
Q quotient kernel of F should go to image of F.
Q by kernel of F. This is isomorphic to some NZ, right?
Yes.
Good. Then
So there will be some element which firstly N will be the generator of NZ.
yes.
So
what?
there will be some element going to this generator.
Not necessarily.
Some element
But
in
it's
Q by
isomorphism.
kernel F going to the
Okay.
N.
Okay. Some element will go to N. Okay, that's I agree.
But
So,
by that, if that would imply that if we multiply this special element which we get by any integer, then we should be exhausting all of NZ. We are exhausting the entire image.
okay, but let's keep it more simple. Like, just go with whatever you know. Suppose F is such homomorphism. Okay, let's assume there is such F. We'll arrive at a contradiction. We'll use the definition of group homomorphism and all those things. And it is defined by, let's say, f of 1 is K. Okay. And assume that without loss of generality, we can assume that K is positive. That's not a big issue. Without loss of generality, we can assume. So then K, we are writing f of 1. So f of 1, we can write as n times, we can write, right? Because this from Q, so 1 by n makes sense in Q. Since f is a homomorphism, we can, this is also n times. That means this is n times f of 1 by n. Even this approach is very much useful in, like, whenever you have Q, you need to do this type of steps. So you have f of 1 by n, that is equal to K by n. This you got. Till now, I just only used f is a group homomorphism. Nothing fancy I have used. That means f of 1 by n. So that element is in f of 1 by n. That element is in Z. So K by n to be in Z. That means this shows that every natural number n, divides K, which is not possible. Only possibility is K is 0. That will give you f of, so ultimately f is 0. Is it clear?
Yes, sir.
Good. So this is the standard approach. Even same approach you can apply anywhere. So for G infinite, like in this case, if the group G is infinite, then you can't see anything. Like for some cases, it has infinitely many, and I have given you one example Q for which it has only trivial homomorphism. So you can't say anything in general. Okay, good. Now, okay, so now let's discuss this problem. This is not from CSIR exam. Surely. Means I have made this question, not from previous year. So first option is if here G is group and H and HK both subgroup of G. And option 1 is saying that if H and K are isomorphic, then the quotient group G mod H is isomorphic to G mod K. Or any option, like if H is not isomorphic to K, will it imply that G mod H can't be isomorphic to G mod K? And suppose H is proper subgroup of G, then can you say that G mod H is isomorphic to G? And if you have converse, G mod H is isomorphic to G mod K, will it imply H is isomorphic to K?
Sir, is G finite? So, group or anything?
G is any group, finite, infinite, nothing is mentioned for G.
Then for A is true
A
and
is true. Okay.
C is false because
Okay, you are saying C false.
and A is true.
Okay, you are saying A is true. See, these are standard exercises, means you can expect this type of thing in CSIR net, surely.
Sir, is in C you have said can be isomorphic. So is it like may be isomorphic or may not be?
Yeah, can be means, yes, can be means it may happen that G mod H is not isomorphic to G. It may happen that in some cases, means some particular G and H, it is possible, but not for in general. Okay. Yeah, someone said D is false. Can you give counter example for D? Means why D is false? Why D is false? Yeah, just try to interrupt. Means if your answer is wrong, that is not a big issue.
Thinking, sir, last one, why last one should be false? Thinking the about example.
Sorry.
Sir, let us take D4.
Sorry, just
For
can.
G, we take D4.
So what is your G here? Means in option D.
Yes, sir.
What is
G
your
is
G?
equal to D4.
D4.
1x x square. Yes, sir.
Okay.
So my H is 1x x square x cube rotation subgroup.
Okay, 1x. This thing.
And K is 1y x square y x square.
Okay. So can you prove that? Okay. So can you find the question? Identify the question then?
Yes, sir. Actually, G mod H and G mod K has exactly two
Like,
elements.
yeah,
So it
D4.
becomes
D4 means you are saying order 8, right?
Yes, sir.
So age, if you quotient by age, that will be order 4 subgroup, right?
No, sir. Order 2.
Sorry.
G
Yeah.
mod H.
Okay. One, sorry. 8. Yeah. Sorry. Yeah.
Okay,
Yeah.
sir.
Okay. So, but is agent K normal subgroup?
Yes, sir.
And
Because its index with G is 2.
2. So normal. Okay. But why agent K are not isomorphic? Can you give argument?
H is cyclic group, but K is Klein for 2.
Age is generated by X. Okay. Yeah. Maybe. But yeah, you guys you can check. Yeah, this is one possible. Yes. So this is isomorphic to Z mod to Z. But please check this thing. Means, like for this, you need to check that H is a normal in G, K is normal in G, and you need to check that H is not isomorphic to K. That thing you need to check. And all those things are fine. Okay.
So for C, we can take G to be Q, H to be
Okay.
Z.
Okay, Q, H to be Z. So here Q by Z, you are saying that this is not isomorphic to Q. That
No, I'm saying it is isomorphic to Q.
no, Q by Z can't be isomorphic to Q. Why Q by Z is
Because
isomorphic to Q?
it will just send R plus Z to R.
Okay, so you are saying R plus Z to R.
Yes.
Is it onto? How will you send 2 plus Z? It will go to 0. 3 plus Z, that will go to, like, so according to this will go to 2, this will go to 3. Right, according to your definition.
Yes.
So is it well defined? Because whenever you are defining from Q mod Z, so you need to check well defined. So is it well defined? Here this element is 0 element, right? In this quotienting, this element is
Yes.
0 element. This is 0 element. So all those 2 and 3. So how will it be well defined? This is not possible. Okay, so there's some standard example. Like for example, yeah, this will work, I hope. But please check. Like for option D, C, you have just, you can think this. Suppose you take G to be C star. Okay. And take homomorphism from G to G, G to G, sister to sister. Take the homomorphism Z goes to Z square. What is the kernel? What is the kernel?
Circle.
Sorry?
It's the unit circle.
This is just right? Right? This is just nothing but a second root of unity. Let's take this to be F2. Now define F3 from G to G. Means G to G means sister to sister. Z goes to ZQ. What will be the kernel?
Cube roots of.
Good. So this is a cube root of unity. So in general, if you have f of n from G to G by Z goes to Z power n, and you have kernel of Fn is nth root of unity. Is it clear?
Yes, yes.
Even check that all the Fi's, F2, F3 up to Fn, all are, this map is onto. Is not it? This is onto. Because you are in C. In C, you have Z to the power n is some W. It has solution by fundamental theorem of algebra. It has roots, right? Over, since you are in over C. Is it clear?
Yes, yes.
Yes.
So that means all the homomorphism we constructed here, all of them are onto. So from first case, what will you get by first isomorphism theorem? C star modulo plus minus 1, that is isomorphic to C star. What will you get here? C star modulo third root of unity or cube root of unity, that is isomorphic to C star. Or in general, you can get C star modulo nth root of unity is isomorphic to C star. So that means here option C is false. This example give you option C false. Means sorry, option C is true, not false. Means I have given you one example for that. H is a proper subgroup such that G mod H is isomorphic to G. So for this case, G is here, G is C star, and this is called H. So G mod H is isomorphic to G. So option C is it is possible. Right? Even here, you can observe one thing that all the HI means that kernel, they are not isomorphic. Like this has 2 elements, this has 3 elements, this has n elements. They are not isomorphic. That means let's assume Hn to be nth root of unity. So you have Hn is not isomorphic to Hm for m not equal to n. But the quotient group G mod Hn, that is isomorphic to G mod Hm, and that is isomorphic to C star. Means I am considering here G equal to C star. That means you have one another option. Which one? Option B is false. Option B is false, right? Because H and K, here they are not isomorphic, but G mod H and G mod K are isomorphic. So this is false. This we have proved true.
D is also false.
D is also false by that example. So one example gives you all those things. And if H is isomorphic to K, then G by H is isomorphic to G by K, G mod K. This you can't conclude from this example, right? Like here H and K are isomorphic. Not isomorphic. So this for this example, from this example, you can't conclude option A. Option B, C, D, you can conclude. So what will be counterexample or proof for option A?
We can give the isomorphism from
and
G by H to G by K.
Sorry, I'll just repeat once again.
H is 2Z and K is 3Z. Then
Nice.
H and K are isomorphic.
Good.
If we take J is equal to Z,
That will work,
then
yes. So just take H2Z, K3Z, and G to be Z. That will give counterexample for option A. Fine. So is it clear? So one example like G C star, that's enough.
Excuse me, sir.
Yeah, sure.
Excuse me.
For C, sir, if H is G is Z and H is N Z, then G by H means Zn, which is not isomorphic to Z. Shall we take that example?
So you are talking about option C.
C, sir. If G is Z, H is N Z, then
Sorry, just okay. So what is your G? What is your G?
G is Z.
Is it? Means sorry, I can't.
Integers.
Integer.
Oh, okay. Fine, sorry.
H is N Z subgroup N Z. Is it possible?
Yes, that's why can be na. Means I am not saying this must be. That's why can be. Like for this example, this is not possible. But I am giving you another example for that this is possible. So that's why can be. Can be means it may happen that they are isomorphic. It may not happen. Okay. Is it clear?
Okay, sir.
Yeah.
Sir, I have a small doubt.
Yes, sure.
You show the next slide, sir.
Yeah, sure. Yeah.
Here, just look at Fn, kernel of Fn is nth roots of unity,
Nth
right?
root of unity, yes.
C star mod kernel Fn is isomorphic to C star.
Yes.
right?
Yes.
So suppose if the question is like this,
Yes.
this C star mod nth root of unity is isomorphic to C star.
Yes.
This is given. Okay. Then what is that isomorphism?
Means from where to where you
I mean,
want.
I'm
Okay,
asking.
okay. So you are saying this is isomorphic to C star, right?
C star.
So that means you want to construct an isomorphism from this, right?
Yes. Mapping, that mapping.
Yes. So see, in practical purpose, it's not easy to, yeah, it is easy. You can define the map, but for practical purpose, like, okay, like here I'm giving you. Suppose you are asked to prove that this thing. So you will try to find this thing, but my personal
No. My question is, this is
yeah,
already given.
that's what you are going to define, right?
Yeah.
So that's the general thing I'm going to tell you, right? This is the setup, right?
Right, sir.
Okay, means you are saying this to be G, right?
G.
Okay, fine. Okay. So you are going to prove that some quotient group is isomorphic to some G. Do not go to means to define homomorphism from here to here. Please do not do that, because whenever you will define something from here to here, since here you have quotient group, whenever you have a quotient thing, that means you have to prove well definedness. So whatever map you will define, you need to check whether the map is well defined or not. So that's little bit difficult to define a map directly from a quotient group. Always try to define a homomorphism from G to G and show that kernel of F is H. That's the standard way, and that's the easiest way to do this thing. Do not go into this trap. Means this is the trap.
Yeah.
Okay. Do not do this thing. Whenever you want to prove something quotient is isomorphic to this, just try to define this map, because for this you can define anything. You need to worry about whether the map is well defined. I mean, you need to worry, but it is not essential. But here all the elements of H is equivalent to 0, so you need to take care of that. That's the easiest way you can use, and also that is onto and show that kernel of F is H. That's the easiest way. Yeah, here also you can define map surely, but that's difficult. That's why I have taken map from sister to sister and show that kernel of this, and onto using this I have claimed this thing. Okay, maybe you can define surely. No, not a big problem. Okay, so this thing, so only option C is true, others are false. That's very interesting. Like that particular group G is sister, that is very important group, like this thing, because all the maps will give you nth root of unity for each n, and all the maps are onto, and you have some special thing here, like you can't expect, no, because if you have G mod A is isomorphic to G. Good. Yeah, so maybe next one. Okay. So consider these two statements. Statement one is there doesn't exist non-trivial group homomorphism from sister to S 2024. That means symmetric group on 2024 symbol, and R star to Z mod 2025 Z. So how will you approach this problem? So my aim is to give you an overview that I do not look at the statement like formula or table, how to count homomorphism. Which question you were talking about? Just please unmute yourself. Yeah.
So just last question.
Yeah, last question means what is your doubt? Yeah.
So option A, like, is it true or false? I didn't get that.
Which? Oh, okay. So you are saying which option you are talking about?
First option.
Yeah, first option is false because take G to be Z, H to be 2Z, and K to be 3Z. Then 2Z and 3Z are isomorphic. But they are quotient. One is Z mod 2Z, another is Z mod 3Z. They are not isomorphic. Okay.
Okay, sir. Okay, thank you.
Yeah. Thank you. Yeah. So now let's think about this problem. How will you approach? Means what is your just intuitive idea? Do not need to solve properly. Just tell me what means after seeing this problem, what will you think? Even surely like 2013 or 14, that time similar type of questions they ask in NET exam, like statement 1. Like if you know the mechanism how to do, then those things means here this group is just for formality. You can replace anything, whatever you want, you will get similar thing. Just you need to know the recipe, how you count. Any input?
Sir, both of them are finite groups.
Yeah, yeah, that's one thing. In the codomain, both of them are finite. Yes.
And from first isomorphism theorem, we know that C star by kernel should be isomorphic to image.
Good. So always, yeah, good. So that's the first step. Always, whenever you have such thing, try to use first isomorphism theorem. Suppose let's discuss about statement 1. Suppose you have F maps sister to this. So by first isomorphism theorem, this bikernel of F is isomorphic to subgroup of this. Okay, so what is your next step? Yeah, please continue. Yes.
I was thinking like this subgroup should be a finite group, but we will not.
Yes, yeah,
find
because this is finite, so
such
subgroup this will be finite. So that means from that you can conclude that sister modulo Rf, this is finite, right? Some finite quantity, this quantity. Yes or no? Is it clear?
Yes, but
Yes.
Yeah. So now the question reduces to means from this. So from this small observation, means small means this trivial observation, you can say from this. So now the question is, that will imply Rf is a finite index proper finite index subgroup of sister. Now the question means to solve this problem, it is equivalent to find how many finite index proper subgroups are there in sister. So the question reduce means question boils down to find all finite index proper subgroup of sister. Is it clear, or you have any doubt till now?
Yes, it is not clear.
It is not clear.
It is clear because we are reducing the problem into the finding of how much finite index kernel is possible in case of sister.
Yes. So is it clear to everyone, or you have any doubt?
Is the meaning of finite index proper subgroup, sir?
Okay. So that means suppose G is a group, H is a normal subgroup of G, H is of finite index if this is finite. Okay.
Okay, sir.
So similarly, for statement 2 also, that side also you have finite group. So same thing, the question is find all finite index proper subgroup of C star. Even I can add more problems also. Like I can create statement 3. Statement 3 is like Q star to this thing. How to compute this thing? Means how many homomorphism are there? So for that thing also you need to consider Q star. So the question is just this. Is it clear?
Yes, sir.
Yeah. So
Yes,
how
sir.
how will you find, means now the question is how will you approach this question? Yeah. How will you approach this thing? Let's discuss about R star at first. Let's discuss about R star. So finite index proper subgroup of R star. Can you give me one example of such subgroup, which is a finite index? One, sir.
R star.
That is improper, right? Means I am asking you
R
proper.
plus.
Sorry. Sorry. Yeah. Just
R plus.
good. R plus. Okay. So one answer came. Answer is someone is telling that this is R plus. Okay. So can you prove that this is finite index? This subgroup is finite index. That means, can you identify this quotient group?
Plus or minus 1?
1 and minus 2.
Good.
Z over 2 Z.
Okay. So can you prove this isomorphism then? Why this is isomorphic to plus minus 1? Good. Yeah, why this is isomorphic to plus minus 1?
We can give a homomorphism.
Yeah, from where to where? Yeah, please continue. Yes.
From R star to plus minus 1.
Good.
Positive reals go to plus 1.
Good. So
Negative real numbers.
So you want kernel to be R plus. So x goes to 1 if x is in R plus, and it will go to minus 1 if x doesn't belong to R plus. And clearly this is an onto group homomorphism. So from this you can conclude that this is and kernel of F, let's call it F. So this. So you are convinced that this is finite index proper subgroup, right? Now the question is, now is there any other except R plus? Yeah, that fine. So is there any? Okay, so I'm telling you the answer. This answer is no, but please do the proof if you are interested. Due to short of time, just I'm not giving the proof. So the as a theorem, you can say R plus is the only, means this is the unique one, that's why I'm using the word the only proper finite index subgroup of R star. Is it clear? Like for NEET exam, if you know this theorem, that's enough. Okay. Okay. Now will do some application. Like for example, that R star to this. How do you calculate this? So you have sure. Okay. Now what can you say about the order of this? What can you say about order of this?
2.
Good, 2. Because we have seen this. Means this will be 2 if means we are assuming that this is finite. Okay. Assume the quotient is finite. Otherwise, yeah. Because for isomorphism, this is finite group, so subgroup is finite, so that. So 2. Now can you conclude how many homomorphisms are there? Is there any subgroup of order 2? Yeah, non-trivial. Yeah, whenever I am saying homomorphism, please treat it as non-trivial. So is there any subgroup of order 2 in Z mod 2025 Z? Is there any?
No, sir.
No. So that means
No.
That means no homomorphism. Because this group has no proper subgroup, no subgroup of order 2. Now can you generalize this result to any group? Just this thing. If you keep this thing in mind, can you generalize this?
So for any MZ, Z by MZ where M is
Not
odd.
Z by MZ. So now general version. Why are you taking Z? Yeah, Z mod NZ, fine. Okay, whatever you are saying. Suppose Z mod NZ, N is odd. In this case,
No homomorphism.
even you can more generally you can say from R star to G such that cardinality of G is odd, then also no homomorphism. Is it clear? Even this is I am assuming finite. Is it clear?
Yes, sir.
Yeah, but if that side is even like R star to G such that cardinality of G is even, then you have
It exists.
yeah, because this quotient is 2. So then for that case, you need to observe this group. Like if this is cyclic, then there will be unique subgroup. So that case only 1. But it depends on the structure of G. Is it clear? Is it clear?
Sir,
Yeah.
it is not me. We will always have
Yes,
one.
yes, sure. We will always have, yeah. I should have known. Yeah. We will surely have, yes. Group homomorphism, yes. So we have covered all the cases, like G can be obviously finite, means odd order, even order. Now go to the case of sister.
Sir,
Yeah,
sir,
sure.
I have a doubt.
Yeah, sure.
Sir, is there only one non-trivial homomorphism, sir, if n is even, or more than one?
Sorry, can you repeat 1 second?
Sir, if R star to G such as G order of these events, is
Yeah,
there
that
only
only one or even it may possible that only one or more than one. It depends on the structure of the group G. Suppose if you take G to be cyclic group, then you have in cyclic group for each divisor there is unique subgroup of order of that order, right?
Yes, sir.
So for that you will have unique group homomorphism. But if G is your non-abelian, some non-abelian group, like if you take S3, then there are
Okay, sir.
3 2-order subgroup, right?
Yes, sir.
So there are lots of possibilities will be there. So that for that case, if you want to handle that case, you have to know what is the structure of that group G. But if that group is odd order, like 2025, so in that case you
Yes,
can
sir.
easily conclude that there is no group homomorphism, right?
Okay. Okay.
Now talk about this thing, C star to G, any finite group. What will you conclude? So what? So the question is, question reduces to
Finding proper
so
for finite order index.
finite index, not finite order, finite index, proper subgroup of C star. So here also the answer is no. So this is not exist. Sorry. That means as a theorem you can keep. So okay, H is a subgroup of C star and H is of this subgroup is proper finite index. Then H is equal to C star. Okay, even the proof is there, means you can do the proof. This is not a tough proof, means this is a very basic argument. So now use this thing. So what can you say about this then? So no finite index proper subgroup means is it clear? Because it has no finite index proper subgroup, so you have
Yes,
no,
yes.
no group. Yeah, means I am saying no group homomorphism means I just mean to say that
Non-trivial.
non-trivial. Okay, makes you.
Okay.
Whenever I am using the no group homomorphism, please treat it as non-trivial. It's trivial always exists between any two groups. Okay, so far everything is right. Even you can do anything like for Q star also you can think of similar type of problem. Now it is easy. You can solve this problem. So for R star this is odd. So there exists non-trivial. So this statement 2 is false. Statement 2 is false means this, and C star 2 this there doesn't exist. So this is true statement. So option A is true. Okay. So you can generalize all those things. You do not need to remember anything. Just you need to learn the how the finite index subgroup structure in this group looks like, all those things. So okay. So till now everything is fine, right? Or you have any doubt?
Yes.
So should I move to ring theory or you are comfortable? Means if you are enjoying group theory, then I can continue group theory. Means whatever you want.
Yeah, I have one doubt.
Yeah, sure.
Here, H is a subgroup of G. H is a finite index if G mod H is finite. Okay.
Yes.
Here, this H is a finite group or infinite group?
Anything. GH can be anything. Like for example, take G to be Z, H to be NZ. They are infinite, but G quotient H is Z mod NZ, cardinality HN.
But here you are here it comes
So
G.
means NZ means you can say that NZ is a finite index subgroup of Z. Okay, because the index is finite.
That's okay, but here G mod H is finite, right?
Yes.
My intuition shows that I have a formula that cardinality of G mod H is equal to
So okay. So
G intersection H divided by
so the thing is that whenever you are reading such thing, so make sure that your G and H, they have to be finite. Otherwise, you can't use that thing. No?
okay, that's not true for here.
Sorry, means see you are talking about
ordinality of G mod H.
You are talking about
G mod H index
means
this is
so you are talking about this thing, right?
For this we have that formula.
So you need so you need more cardinality of G and cardinality of H to be finite.
Okay.
Otherwise you can't use, no? If G cardinality of G, cardinality of H is finite, then this quotient is finite. In that case, that is true.
Okay, but in our discussion, neither of them is not finite, no?
It can be. Like for this R star sister, they are not finite. Yeah. Like here you have this subgroup, this is H and this is J. So G and H both are infinite. So we can't use that formula. That formula is applicable if you have all those quantities are finite. Like for example, you have order of f of a. Suppose f is a group homomorphism. Like for example, if you say f is a group homomorphism from G to G prime, then you have order of f of a divides order of a. This formula holds if order of a is finite. Otherwise, you can't use. Even you can prove that order of a is finite. That will imply order of f of a is finite. So order of a is finite. That is important, right? Otherwise, you can't use this thing. Is it clear?
Yeah, sir. Yes, sir.
Yeah. So one general fact mentioned by Shomodev. Yeah, like if you have divisible group, you know what is divisible group? Maybe some of you are familiar. Then it's as a general fact, you can prove that divisible group can't have proper subgroup of finite index. Even from that, you can conclude that sister is divisible. Yeah. So if you know what is divisible group, then that's okay. Okay, fine. So should I continue with group theory or move to ring theory? Maybe you can continue group theory, right? If you want. Hello?
Yes, sir. Group theory content.
Yeah, okay, then fine. So like for sister, do the proof. Yeah, even you can prove more generally for divisible group. That's you can do. Even same thing you need, like you have to solve this type of things. You can look at the proof. Okay. Okay, now
So definition of definition of divisible groups.
Okay. Anyone? So anyone are familiar with divisible group?
No, I have no idea.
Okay. So okay, let's define this. So suppose you have an abelian group G. It's divisible. Means you can say in one word that for every positive integer n such that n g equal to g, you can say, but I am writing proper definition. G plus is divisible if for all integer n and for all y belongs to G, there exists x belongs to G such that in x is y. This is the definition of that. Means in G is same as G. For example, Q is divisible. Like take any element from Q, let's say 2 by 3. Then for all integer n, you have, and this is an element of Q, but Z is not divisible, you can see. Z is not divisible.
Excuse me, sir.
Sorry?
Sir, can you please repeat the definition or write?
Okay. Suppose you have one abelian group. That group is said to be divisible. Here you have some divisibility type condition, right? Means for all integer, means if take any integer, and for all y belongs to G, there exists x such that n times x means x plus x n times. That is y. This you can think as divisibility thing.
So can you recall the property of this? As in you said, if it is divisible, then something else happens, right? So what was that?
Sorry. If this condition holds, then we'll say that the group is divisible. Like for example, Q is divisible. Like you can write, given for all integer n and for all y in Q, you will have some x in Q such that n is equal to y. Because x will be just y by n in Q. But in Z you can't get. Suppose you have n times some integer 2, that is some integer 3. Is it possible in integer? It is not possible, right? Or you can take an integer n and this is integer, and if you take G to be Z, then xy will be integer. So this equation in integer you can't solve, no? This is not solvable in integer, but in rational, even any quotient group of divisible group is divisible. Yeah, but for net purpose, if you know divisible group, that's fine, but you do not need to worry about this. Yeah, I mean, like if you, this is certain class of group. If you know some properties of divisible group, then that will happen for Q, even happen for Q mod Z, all those things. For example, if I give you one, like there was one question like this thing, is there any non-trivial group homomorphism? So you can argue this way, like Q by F is isomorphic to a subgroup of Z. Since Q is divisible, this quotient group is divisible. And this is not divisible. So they can't be isomorphic. I mean, there doesn't exist any non-trivial group homomorphism. This way you can argue. Even like I have given you one proof that using normal by using the definition of group homomorphism you can argue. Yeah. So yeah, don't worry about divisible group. You can. Okay, so now, yeah, now.
Sir, you said Q is divisible. So how is Q divisible?
Sorry?
Okay, Q is divisible, not Q star, right? Q is okay. Q star is not divisible, right?
No, Q star is also divisible. Why not? You will get a
So
Q
there,
star, but
Q star, you will have to take Q square, and also square roots
why
have to
you
be
need
there.
square?
Because your plus is product now. So n times will become
Okay.
n
Okay,
power.
so fine.
Yeah.
So for that, yeah. So that will become right. Like, yeah, here for C star.
Yeah, C
That will
star it's
become
fine, but
this.
only for Q. Yeah.
Yeah, for Q star, that will be the equation same. Yeah, but for Q star, yes. Okay, good. So you are saying Q star can't be divisible. Yes. Yes, fine. Even R star is
Even
also
R
right.
plus. R star.
Yes.
Yeah.
R star, R plus, yes. Because you need to have that solution of the equation like y power n is x. You need to. Yes. Our C star, it has solution. It's by fundamental theorem. Yeah. Yeah, Q star is not divisible. So, okay, so here you need to identify, means all the options you need to identify the quotient group. G mod A is here also G mod A. So for option A, you have G sister, and H you have Sharkle group, you all know. So what will be the quotient group? How will you identify this quotient group?
we can give a group population from C star to R plus.
Yes, okay, good. So you want to define group homogeneity from here to here. How will you define?
Z goes to mod Z.
Great, Z goes to mod Z. So then the kernel will be just H1. Is it clear to everyone? Good. So just define Z goes to mod Z. Then the kernel will be H1, and clearly this is onto. So we have sister mod H1 is isomorphic to R plus. Good. Now what about option B? You have R star and H is plus minus. So for B, you have G is. That we have done, right? Yeah. This thing we have done, right? This option B.
Yes, sir.
G mod is isomorphic to R plus. So you need to define. How do you define? Such that kernel will be plus minus 1. Sorry?
Mod of X.
Yeah, mod of X. Even you can send this, or you can send X goes to X square also. Then the kernel will be plus minus 1, and this is onto homomorphism. So done. Now what about option C? So this is true. R2 plus and H is the x-axis. So G is your yeah. Can you identify the quotient group? How will you send means? So if you want to prove that this is isomorphic to R plus, so for this you need to define a
Linear transformation from xy to
Projection
x.
we can use.
Yeah.
that. So you want kernel to be x-axis. That means y, right? Then the kernel will be x-axis. And if you have y-axis, then you need to send x projection first forward. Yeah. Option D is you have R plus and you have Z. So can you identify the quotient? How do you identify the quotient?
Right, 2 pi.
Sorry, your voice is breaking. Hello.
Okay.
It is like isomorphic to S1.
Yes. So for this you need R2 H1 x goes to e to the power, right? Kernel will be Z. Hence, R mod Z, even this is on to R mod Z is isomorphic to H1. Now the question is, what can you say about R mod Z and R mod 2Z? Are they isomorphic? Or similar?
So I have a doubt, sir.
Sure.
Please, this is here and in D, G equal to R plus, right? H is equal to Z. You are asking G mod H is isomorphic to what, right?
Sorry. Which option are you talking about? C.
Hello.
Hello. Which options are you talking about? Option A, B,
D,
C.
D, option D for Delhi.
Okay. D for Delhi. Yeah.
Here G is R comma plus.
Yes.
H is Z. We need to identify G mod H, right?
Yes.
We are defining a homomorphism from R to S1.
Yes.
Here, in previous questions, somewhat I understand how we are defining the homomorphism from first question. I understand R star to R plus. We are assigning the mapping as X goes to mod X.
Yeah.
Second, also I understood here X axis is there. So R2 to R, I am understanding. Here I don't understand this one. Why we are assigning the mapping from R to S1?
Good. So anyone wants to give any answer to, means he's saying why are we defining R to S1 in this way? Anyone?
Because of making kernel as a Z.
Yeah. Anyone else?
S1 is unit circle.
Okay. Because of making kernel as Z, how do you know if you fix the codomain as S1, kernel should come as Z, sir?
Because in circle, e to the power 2 pi x I x time, right? So when will it be 1? Means
That's okay for if we fix some other set here in the codomain.
Right.
That's what I my question.
So when that will be 1.
My question is, rigorously I'm telling, I want to define a function f from G to some G star.
Yes.
Such that kernel of
yes. So whenever you are going to define G to G star, so at first you need to identify what is G star or possible G star, right?
G I know. I want to find what is that G star.
At first, yeah. So at first you need to get some G star, and you need to define such a way that kernel will be H. So that G star you need to guess, because here G star is H1. That's why exponential map will work, and for this kernel is Z.
Okay, that I'm asking that thought process, how that S1 came. That's what here, because why I'm
You
having
need
this
to
doubt
guess.
means
Means I do not think.
the here this R is if we see R is
Yeah,
one
for
dimension.
this, yeah, that's what that's is from. That's okay. This is some geometric thing. Yeah, here also you can find geometry also, like R mod get S1 you are getting. That's okay.
That's what my question.
Now, but given any G, you want to identify the quotient. So for this, you need to know that G star. Otherwise, it's difficult, no? Like for any arbitrary G, that's difficult.
Okay. Other than that, any other isomorphism is there, sir?
I mean, for R by J to S1. No, I do not think there will be, because circle you have cos theta, cos 2 pi x, sin 2 pi x. I do not think, maybe there are, but I do not think. Maybe you can check. I'm not sure. Okay. Maybe there will be examples. Yeah. Okay. So now the question is whether R mod Z and R mod 2Z are isomorphic or not. Or similarly, like for example, R mod MZ isomorphic to R mod NZ or not. Even same type of thing you can think in terms of this. So what can you say about these quotient groups? Obviously, here I am taking m not equal to n, otherwise it will be isomorphic. What can you say? Means can you produce isomorphism between either R mod Z? Means same thing for Q mod Z or Q mod 2Z or whatever you want, either left one or right one. Hello proof. Like for example, if you want to prove this thing, or let's say 2Z, how do you prove? So go through that general way. Try to define this homework. How do you define? Such that you need to define such a way that kernel will be 2Z. Take any rational, send it to. So what are the 0 elements here? Those are multiples of 5. And any elements will look like some Q plus 5Z. So you want kernel to be 2Z. So you need to scale it. Just put 5 by 2. Check that kernel is 2Z. Because whenever you have some multiples of 2, that will give you multiples of 5, then that will be inside 5Z. So that will give you 0 elements. So kernel is 2Z. Is it clear? Even this is.
Yes, it is clear.
You can approach.
Sir.
Yeah.
Actually, this kind of argument only I'm asking for that question.
Yes, because yeah. See, here you know this thing, na? That's why it is easy to define. Here also you know this thing. So whenever you want to identify some quotient, you need to know that this star.
Okay.
Right.
Correct.
Otherwise, that's difficult to guess. Like I can give you some arbitrary group G and arbitrary subgroup. Like for example, I am giving you some pre-group generated by some set and you have some relation. I want to identify this. That's little bit difficult. Like for
I understood, sir. Understood.
So for that you need to know what is this star. So kernel is 2Z. Similarly, you can use this approach to prove this Q mod NZ. This is isomorphic to Q mod NZ. How will you prove? So define this way. Some NZ unit, so that means sorry, Q plus NZ. So your kernel will be NZ. Even you can do the same thing for R mod Z also. Even in general, this is true. R mod MZ is isomorphic to R mod NZ is isomorphic to R mod Z, which is isomorphic to H1. Here I am taking M not equal to. Is it
Sir,
clear?
here we can easily say R by NZ is isomorphic to S.
Yes.
From the same homomorphism we use for R by Z. We'll just give X goes to E power 2 pi
No,
I.
you can do the similar scaling right here also. Like whatever for Q, you can do similarly. You can scale, no? Is it clear?
Yes, sir.
Yeah. So yeah,
Sir, behind this, any geometry involved, sir?
see, for R mod Z, yeah, see, here you are getting some structure. Obviously, there will be some geometry for H1. Like here, it is this groove. Yeah, you can think this as inside nth root of unity, inside sister, you can think Q mod Z. Yeah, but here that will be S1 is topologically you can see this thing inside R2. This is compact. So obviously R mod Z will be compact.
Okay.
Those things I can do, but like someone means who is that? Okay, so but I can't. Yeah, it is difficult to see. Okay, so someone Amazon Prime. Okay, R cross. Okay, this was asking TIFR, right? So its question is his or her, I don't know. R is the ring CX mod X square, and R cross with a multiplicative group of units. Then is there any injective group homomorphism from Z mod to Z cross Z mod to Z into R star? That was asked in last time TIFR, I think, not last year. Okay, so maybe we can discuss that problem. So R is this ring. Now you need to find R cross is what. Now the question is whether you have group homomorphism from this to this. So you know this is a group under multiplication. So whether you will have a group injective group homomorphism means can this group K4 can be embedded inside R star. So the part is how to compute R cross. So Amazon Prime means can you unmute yourself? Means how can you compute R cross? Means have you thought about that? Means how the okay at first tell me. So you can leave and join again. How the elements of R looks like? Can you identify the elements of R? Yeah, can you identify the elements of R? Okay, you can write in chat also, no issue. How the elements of R looks like?
A linear polynomial plus
Good.
X.
So this is just A plus Bx such that AB from C. This is the polynomial. Now find how among these elements, what are the units? That means you need to find A plus Bx times C plus Dx. That is 1, right? That means if you just multiply and compare the coefficient, you have AC is 1 and all those things are 0. So that means units of this group is unit group of this ring is just nothing but C star. Means all are non-zero numbers. So just consider this to C star. Now this is easy. You can do that problem. So you have some ring. Now you reduces to group theory problem. What are the elements of these loops like? This is 0, 0, 1, 0, 0, 1, 1, 1. These are all elements of finite order. Even order, all the elements have order 2. Now, now it's task to find how many finite order elements are there in sister. What are the elements those who have finite order? Even you can think, since this is an injective homomorphism, these elements, suppose let's take this to be F. Let's call it A, let's call it B, C, D. So obviously order of F of A, that will be finite. Even that will divide order of A. That means order of A, H1. B, all the other elements are of order 2. That means you have order of F of A divides 2. So you have possibilities. So now find what are the elements of order 2. Then just try to find the map. Surely there will not be exist. You can check. There doesn't exist any injective homomorphism from Z mod, means the statement is false. You can check this way, just using this two things. Is it clear? Amazon Prime. Good. Okay, so maybe today we can stop. So just maybe whatever we have discussed, how to find group homomorphism, like given any two arbitrary group, like special group, how to find group homomorphism. I think that much you can understand when you can use in exam also, in your exam. Like R star, C star, Q star. Even you can create your own problem and you can think. Okay, so any other questions from your side? Yeah, Pallavi. Pallavi, do you have any questions? Means you have raised your hand or by mistake?
Sir,
Yes.
in the second question, you said that
Second question
number,
means second question.
in this whole section, second question, number of group homomorphism from Z 150 to
Yes,
Z9.
GCD, yes.
If I take Z6 to Z9,
Z16 to Z19.
I take Z6 to Z9.
So whatever M and you are taking, you can just take GCD. Means. Okay. Suppose you have Z mod MZ to Z mod NZ, then number of group homomorphism will be GCD. Okay.
So suppose I take M is equal to 6 and N is equal to 9.
9.
9.
So just take the GCD 3.
But then you give a proof, right? F of 1 is equal to some X.
No, but that is from C. So for that proof, what was my domain? That was Z, not Z mod MZ. See, this was from Z to Z, not Z mod MZ. This is from Z to Z.
No, sir.
Sorry?
First you say that if F of 1 is equal to some X,
Yes.
then order of F of 1 divides order of 1, right?
Yeah, just use this thing now. This condition. So what is okay? So let's do
Okay,
this.
then
Yeah, Z.
I think F of 1 is equal to
See, this to this, right?
So
what is your F of 1? Tell me. Let's take X, right? So order of 1 is 6. Order of X is 9. And group if is a group homomorphism, then that will divide means order of x will divide order of 1 means 6. Means see x means that is not the case because this can be anything. I can't say anything about order of x. So order of x is a divisor of 6 and x is an element of z mod n z. So order of x divides n. So just what are the possibility of order of x?
1 and 3, right?
So you got no
1 and 3, right?
1, 3, 9. So you have 3 homomorphism. You will get maybe just you need
Order
to,
of x divides 6.
order of x is 1. That means x is 0.
And the order of x divides 6. How can we get 9?
Sorry. 1 and 3 only. Sorry. Yeah.
Then GCD is equal to 3, right? GCD of 6, 9.
Yes. So you will get 3 homomorphism. Order of x is 3. That will imply what are the elements of order 3 here? What are the elements? 3 and 6. 6 has order 3. 3 has order 3. So what are the homomorphism? F of x equal to 0, f of x equal to 3x, and f of x equal to 6x. These are the order, not the elements. So these are the 3 homomorphisms.
Okay, sir. Thanks.
Yeah, good. Okay, so okay then. Yeah, I'm done.
Okay.
Sorry. Yeah, sorry.
Yeah, Debajyoti, our time is almost over. Shall we?
Yeah. So, hi. Yeah.
Okay.
Okay.
So thank you, Debajyoti, for this nice session with a good collection of problems.
Yeah.
And I have seen that the session was really very interactive and people are really raising questions and interacting.
Yes, that's what's very nice. Yeah. Yeah. Questions.
So I'm sure that those who have seriously attended the session have really got many inputs.
Yeah, even like for ring theory part, I'm not able to cover today. Means if they are okay, then before NET exam I can take one more session. I'm okay with that.
Okay. Yeah, we can plan one more session. I think.
I'm okay with it. Yes.
We can decide the exact date and after the class we can in WhatsApp we can discuss it. Okay.
Yeah, sure. If they are interested.
Yeah.
Then I can.
Yeah. Some people in chat box also requesting for the session in ring theory.
Okay.
So
today I have covered group theory. Yeah, just one session. Like do the from group theory part, from silo part, do for the group of order 2024 and 2025. Means that are obvious questions. Like whether that particular or group of that order, particular order, they are simple or not. Or what are the silos of group or something. Those things.
Okay. Yeah, dear participants, now it is a time for your feedback. You may share the feedback. Yeah, some of them are writing in the chat box. If any of you would like to share your feedback, feel free to share it now.
Yeah, surely. So you have one feedback form, right, or something?
Yeah, not exactly. We are not collecting such feedbacks, but we are entertaining them to express their feedback in the session itself.
Okay.
Yeah, Archana, you may.
Good evening, sir.
Yeah.
So actually the session was very interesting and very interactive. You made the topics very simple and it was like clear.
Yeah, like you can,
Yes.
one generalization is whatever group I have taught, you can generalize. Like you can think your own questions, you can create questions and you can think in yourself. Like
Yes, sir. Yeah. Thank you so much, sir. So I'm actually a UG student, so like some topics are not familiar.
Yeah, for UG student, that's little bit difficult.
Yes, sir. But like
yes,
sir. But it actually you motivated a lot for going to that deep question.
Like means I have seen some people that from group counting of homomorphism, they just took some notes and some table that if the group G is this and G prime is this, then just homomorphism will be number of homomorphism will be this. But that's not the right way. Just try to understand how to count.
Yes, sir. Yes, sir.
Yeah.
Thank
It
you
was
so
a nice
much,
session,
sir.
Debajyoti. Hello.
Yeah. Thank you.
It was a nice session.
Thank you.
Yes, sir. I am 𝕨𝕚𝕥𝕙 from Kasganj, UP. I am preparing for IIT JAM also. I want to ask about your PhD journey and how to choose problem and how to do literature survey for any particular field.
Means
Can you tell about your topic?
So you want to learn means before PhD journey or after PhD how to do literature survey, or what is your actual question?
Before PhD.
Oh, like see, before PhD you need to qualify some standard means national level exam like NET, GATE, NVHM, whatever. After that you need to apply some IITs, NITs, means whatever you want. And based on your national level exam, you will get shortlisted based on your rank in national level exam. And from that, you will get shortlisted and you have to give written exam, interview. Means it depends on, it varies from institute to institute. Like some institute take written exam and then interview, and some institute take only interview. So that depends. And if you clear written interview, then you will get selected. Like this type of class, it will help you for interview purpose, surely. Like they will give you some group homomorphism to count, but if you say just only formula, they will ask you surely the proof. What is the proof?
So can you tell about your PhD journey also?
Oh, so yeah, like I have completed my MSc in 2021. Okay, but after that, I tried for PhD position in like for my time there was COVID. So in 2021 there was no NET exam. Even that time NET exam was very much irregular. So yeah, I qualified GATE 2022 and I have given an interview in many some of the IITs in July session, but I didn't get selected that time. So after that in December session, I got selected at IIT Hyderabad and then IIT Madras, and I took admission here. Like due to COVID, the things was very, that took one and a half year after my MSc. But those are in MSc, please try to clear NET GATE in your MSc time. Like this time, NET GATE, all the things are going smoothly. Like our time, 2021, there was no NET exam.
Yeah, because of the COVID.
Because of the COVID, yeah.
Okay.
Actually, your sessions was very good, sir.
Yeah, thank you.
In the span of 2 hours time, I think you have told many isomorphic groups.
Yes.
How to see one group, two different group as a same group in a very clear manner, sir. I heartily enjoyed the session,
Yeah,
sir.
thank you.
you.
Even you asked so many nice questions to me also.
Yeah, thank you.
Yeah, that question I didn't answer you properly. Maybe there are some reason like why R2 H1 means how to find that G star. Even my feelings is saying that you need to identify G star, otherwise you can't talk about.
Oh, okay. It was really very good session, sir. But especially that what to say, that S1 came na. F from R mod is at
2S1.
2S1. That is I really enjoyed it. But I want to know why we fix that S1. That I want to understand something about that.
Yeah, I will also think about that. Means but you need to know, means if you want to identify G mod H to some certain G star, then you need to know what is G star. Otherwise, it's difficult. Maybe, yeah, I will think about that also.
Okay, sir. Thank you, sir.
Okay, 𝕸𝕒𝕦𝕨𝕚𝕨, could you introduce yourself?
I am a maths teacher, sir, in Madurai, near Madurai, Aruppukkottai, one school I am working. I am working as a IIT JEE trainer, sir.
Okay. Okay. Thank you. You are very active in the discussion also.
Yeah.
You know, sir, long time back only I studied group theory and all. Now, last 1 month I am preparing for this NET exam. That's why I am actively involving.
Okay. Okay, see, we usually used to arrange this type of sessions. So whenever possible, try to attend such sessions.
Okay, sir. Okay, sir. Thank you, sir. Really, it was very useful session, sir.
So I think any other, yeah.
Sir, your reasoning for every question is very valid, and thank you for explaining almost clearing everyone's doubt with patience, sir. And thank you for sharing your experience too. Because many people will give up because, like, since you said you tried for almost 1.5 years and you got into IIT Madras, so it will help so many people, including me. Thank you.
Yeah, thank you all for joining the session also. Otherwise,
yeah. So let us wind up here. Once again, my sincere thanks to Debajyoti for this nice session. And we can plan our next session before the NET exam itself.
Yes, surely.
So thank you, everyone. Let us wind up here. Bye.
Okay.
Good night.
Bye. Good night.